Hello, welcome back to my tutorial for the Fullstack Developer series. And today we continue with the typescripts for the reference functions and the closure. Okay, so the first is the reference function. The reference function is very simple to understand. Normally you create a function like this, right? Function, for example, print the name, something like this. And inside it, you maybe use the console to log something like hello and some name. Maybe you create a name, full name equal Jade Engineer, maybe, and plus the full names at the end of the string. Alright, and then you want to call the function, you will do something like this: print name. Okay, you will do this. So this is the normal way that we most of the time do, but in TypeScript we can do something like create a reference to a function as a variable. Very cool, right? So you can create something like var a equal, okay, or you can even assign the var a directly like this. Okay, then you can call the a as a function like this. So let's run to see. Alright, you can see we have hello J engineer like this by calling the a function as a reference. Okay, now we move to the closure. So first I will talk to you about the definition of the closure. So closure is when a function is able to remember and set its lexical scope even when the function is executing outside its lexical scope. So let's create an example to see. We can create a function named get the greeting with two parameters. It's the first name and the last name. Okay, and inside the function we create a name intro. Okay, it's not. I just create a reference function greeting. Okay, and create a function. So we have learned about the create function inside another function, right? So this function is a lexical scope, and inside the function we just return a string, something like hello, and we plus the first name and then a space between the first name and the last name. Okay, very simple. And so in the finally we just return the greeting. So what does it mean? The get greeting function just return another function, which is the lexical scope function. Okay, so please take a note on this one. Okay, and then we create a variable name greeting J, okay, equal get greeting Jade Engineer. Okay, and you can create another one, greeting John equal get greeting John Dave. Okay, and now you can call something like this: console log greeting J. Okay, and you can also console log greeting John. So how you think the result of this? In the normal case, we need to understand that when you change the first name in here to John, right? So the greeting function, you see that when you call the greeting to J, right? That means we are calling the function greeting inside the get greeting function. But now when you call greeting J, after we call the get greeting and we assign a new value for the first name and the last name is John and Day, and now the first name is John and then the last name is Day. So when we call in the greeting J, that means we will see the result that hello John date, and greeting John is also the same result, right? But wait, let's run the example and see what happened. Okay, you see that hello J engineer and hello John day. So why? So let's talk about the definition of closure again. Closure is when a function is able to remember. Okay, remember what? Remember the first name and the last name, right? And as said, it's lexical scope. Even when that function here is executing, the function here is executing outside its lexical scope. So that's why we have the result like this. It can remember the first name and the last name when we call get greeting before. Okay, just remember that. All right, I think it's easy to understand, right? And next, from this one, how the closer work with the loop. So let's create an example to see the problem. Create an example for an index I from 1 and the I less than or equal 5, and I increase every loop, and in the body of the loop I create set timeout. Inside the set timeout I put a function. Alright, I will define a function in timeout. And in the body of the timer I just conserve the log I like this, and the timeout should have the time, right? I multiply with 100 because I assume that I is a second, so I multiply with 1000 because the time in TypeScript measuring by the milliseconds, so I need to convert the second into the millisecond. Okay, and when we run this, you assume that we will see 1 2 3 4 5, right? So let's run to see what the problem. All right, you see that we receive 6 for all. Why? All right, this is a asynchronous, right? So after after 1 second, the timer will finish, then it show you the eyes. Okay, but the eye now is a reference. Okay, please take a note on this. Please, the eye now is a reference to the eye, which is 5 when the loop for when the for loop is finished, right? When the for loop is finished, the eye is 5, and I here is a reference. So in the last of the loop, for increase I, we have 6 here, right? So that's why the console here is not remember the I. So to make I is remember, think about the closure that we have learned before, right? The closure function can remember, right? Can remember the param that it receives. So let's make a fit. Okay, let's make a fit by using the closure. So just create a function, raw timer equal function with the I, right? So when we put the I here, I now is the parameters, so it can be remembered. Okay, so inside this we create a timer and create a function timer. Inside this I multiply with 1000, and inside this we just console log the I. Okay, and in here we just call the timer. Okay, see this function is a lexical scope, right? So it will remember, this function will be will remember the I like a previous example. You see that? So we can put the I here. Now the I's will be remembered in the function timer. Okay, and now let's run. I hope you can understand this, because I'm trying to show you in very detail, so you can understand more clearly about the closure and the loop closure and the function and how reference function, and I believe that you can understand. Okay, all right, so you can see here we have 1 2 3 4 5. Very good, right? All right, so that is the closure and the look. So because you see that, because we can create a function inside a function, and you can see that we can the function can remember the parameters that we put inside the function. So what does it mean? Let's think about how can we do with the function, with the closure function like this. Whether can we simulation the OOP, simulation the class, right? So let's create an example to see. Now we instead of creating a class student, we can create a function student like this. Student. Okay, student is now is a function. Please note that. And inside function we create a variable name and a variable age, and we return an object. Okay, return object, and inside the object we have the methods set name. It's the function return a value. This function return a value, a parameters that can be assigned to the name, right? And we can also have another attribute or another item, because this is the object. Okay, remember the objects which we have learned before. If you don't have knowledge, please come back with the previous video to see what are the objects. Okay, and another is get name, is also a function with no parameter, just return the name. Okay, so please note that the name here and the name here is inside a lexical scope, so it can be remembered. Okay, please note that. And set age is the same, it's a function, it's value age equal value, and also get age function turn age. Okay, so we finished to create a student function, and now just create student. Now student here is not an object. Okay, student here is a function as a reference. I'm sorry, but the function, this function student just return an object. Okay, so we can return a new, not new, student function, because the function student will create an object by using the curly brackets like this, and inside the student you can call the set name like this, be A, and you can call the set age 5, and now let's log the name of a student get name. Okay, and student age get age. Alright, clear this and run. Okay, you can see we have the A and the 5 result here. So that means we can simulate the OOP by using the function like this. Okay, I think that's all for this video, and if you have any question, please comment below, and if you liked the video, please click the button like and subscribe channel. That will make me happy to create more interesting video for you. Okay, thanks for watching, and see you in the next video.